This video is going to be part 3 for October 13th and 14th. We already did parts 1 and 2. Last video should be looking at triangles. And we're going to do 2 of these and I'll let you do the rest. But here we're trying to find sine of arc cosine of 1/2. And hopefully the idea is that if we're using the inverse trig functions like arc cosine, arc tangent, arc sine, cosine inverse, cosine or sine inverse, tangent inverse, then what those functions are telling us are different angles. So ultimately what's happening is this arc cosine is going to tell us an angle. We don't know what that angle is yet, so let's call that theta. Okay. So big idea is we're going to find sine of theta. Now, this is telling us something. Here it's 1/2. We know it's going to be positive, so our triangle will extend into the first quadrant. Right angle, theta would be here. And what this is telling us, arc cosine of 1/2, really is just telling us that cosine of theta is equal to 1/2. That's what that's telling us. And we also know that cosine is adjacent over hypotenuse. So in terms of theta, adjacent is going to be here. That's going to be 1. Our hypotenuse is going to be 2. That's here. And so we know this about our triangle. Now we're trying to find sine, which means we're going to need to have the opposite side. Let's call that b. And we can solve for b using the Pythagorean theorem. So a would be 1. We could do 1 squared plus b squared equals 2 squared. I'm going to simplify and solve this quickly. If you need to pause it at any time, that's fine. We find that b is equal to the square root of 3. And so now we have everything we need. Sine is opposite over hypotenuse, opposite over hypotenuse. So sine of theta is square root of 3 over 2. And this is our solution. I'm going to go ahead and turn to the next page. Go and do that second one and then maybe additional one on top of that. So again, we have tangent sine inverse of 6 over 7. This is telling us an angle, so we're trying to find tangent of our angle theta. This sine inverse is telling us that sine of theta is equal to 6 over 7. It's another way we could write it. And we see that sine is positive, so again, we're in the first quadrant. Right angle, theta is here. And sine is opposite over hypotenuse, opposite over hypotenuse. So this would be 6, because that's our opposite side. Our hypotenuse is 7. Now we need to find tangent of theta, which is opposite over adjacent. We don't know what that is. I'm going to call that A. But we can solve for it. A squared plus 6 squared equals 7 squared. Yeah, I'm going to solve this quickly. If you need to pause it all, that's fine. So we get A is square root of 13. Now we have everything we need with the triangle. Tangent is opposite over adjacent. So we say 6 over square root of 13. Because we have a radical or a square root in our denominator, we have to rationalize, multiply numerator and denominator by the square root of 13. And we end up with this value. And that's it. I'm going to do one more. I'm going to do number 4 here because I see that as a possible hiccup. Here we know that tangent is negative. If tangent is negative, then we're going to be in the 4th quadrant. So what's happening is our triangle, if you will, is going to look something like this. theta is here. So we're trying to find sine of theta. This is telling us that tangent of theta is equal to -2. But we also know it's also going to be -2/1 if we want to write that as a fraction. And so if we do opposite would be 2, adjacent would be 1. One of these has to be negative. If we move to the right on the x-axis, that's positive. If we go down on the y-axis, that's negative, so this will be negative. Sine, we need opposite over hypotenuse. Well, we already know the opposite's -2. We just need to solve for the hypotenuse. C, so we could do 1 squared plus -2 squared equals c squared. Again, doing this quickly. So c is square root of 5. That means sine of theta is -2 over square root of 5. We would need to rationalize our denominator, and that's our solution. Again, I know I went a little quick there. However, if you need to pause it, go back a little bit, make sure you understand what's happening, that's fine. Also, if you have questions, please feel free to contact me in any form and talk about what's happening.